Lesson 2.5 Reason Using Properties from Algebra. This lesson might seem a little easy in the beginning, but I would like you to focus on the different properties that you will be using in future proofs that may be more complicated. Algebraic properties of equality. Let A, B, and C be real numbers. So we have the addition property. If A equals B, then if we add C to both sides, the equation is still balanced. Subtraction property. If A equals B, then A minus C equals B minus C. Multiplication property. If A equals B, then A times C equals B times C. Division property. If A equals B and when C does not equal to 0, then when you divide by C to both sides of the equation, it is still balanced. And then we have the substitution property. If A equals B, then A can be substituted for B in any equation or expression. Even though these properties look very simple, later you'll need to use them for proofs in geometry. But I would like to first show you how to use them when it comes to solving equations. So for example, in example 1, you have the equation 2x plus 3 equals to 9 minus x, and then you're being asked to solve this, and you will have to provide a reason on the right hand side, and that's the focus for this lesson, not on solving for x. That you should be able to do. So the next step here, we want to add x to both sides, and this will be the addition property. The first step will obviously be given. Okay, and moving on, we would add 2x and x together to get 3x. And on the right hand side, the negative x and positive x will cancel out, and you'll get 9. And the reason would just be simplify. And then we take subtract 3 to both sides, be 6. And this would be the subtraction property. And next, we solve for x, which is divide by 3 to both sides. So we have the division property. And I want to review the distributive property, is where you would take the factor of a and you multiply it into each term inside the sum of b plus c. So this would be ab plus ac, where a, b, and c are real numbers. Okay, let's try another one. So the first thing you will have to do is write given as the reason. State the equation. And the next step is to distribute the negative 4 into 6x plus 2, which is negative 24x minus 8. And a reason would be the distributive property. And then minus 8, we're going to have to add 8 to each side, and that will be 72 on the right hand side by the addition property. And then I would divide by negative 24 to both sides. -3. So your reason would be the division property. Okay, let's try one more. This one, for the first step, you would just simply write 4 times 5 minus x equals -2x. Reason is given. And then you would distribute the 4, so that'll be 20 minus 4x equals -2x by the distributive property. And then you will have to add, combine like terms, add 4x to each side. That will make 2x. So by the addition property, and you would divide by 2 to each side to get x equal to 10. So it would be by the division property. Okay. Now try example 4, and then continue to play the video after you are done. So for example 4, you're not actually solving for a solution. You're just rewriting the given equation in the word problem in terms of the speed. So S would equal to d plus 17.5 divided by 3.5. And first, you would always write given for the given problem, and then you will have to use the distributive property, followed by the addition property, and then the division property. Okay, now let's move on to a couple more properties that will be very helpful for future proofs. So here we have the reflexive properties of equalities. Okay, when you have real numbers, for any real number A equals A. For segment, AB equals AB. For angle measure, for any angle A, measure angle A equals measure angle A. For symmetric properties of equality, for real numbers, for any real numbers A and B, if A equals B, then B equals A. For segment length, for any segments A, B, and CD, if AB equals CD, then CD equals AB. And for angle measure, for any angles A and B, if measure angle A equals measure angle B, then measure angle B equals measure angle A. And then the transitive properties of equality. This is going to be a very widely used property here. For real numbers, for any real numbers A, B, and C, if A equals B and B equals C, then A equals C. So if you look at it vertically, it would be like that. And for segment length, following the same logic, if you have segments AB, CD, and EF, if AB equals CD, CD equals EF, then AB logically will be equal to EF. And for angle measure, for any angles A, B, and C, if measure angle A and measure angle B is equal to measure angle B, and measure angle B is equal to measure angle C, then measure angle A equals measure angle C. Now let's look at example 5, and it's more of a geometric proof. And we would like to show that segment CF is congruent to segment AD. So I need to analyze this picture here. What are my given information? I see that AB is equal to EF, so I'm going to write that down. I also see that BC is equal to DE. And my reason would be given for the first step. And now I'm thinking, to prove this, I can take the total length AC and add it to CD and set it equal to DF plus CD. But I need to break this down here. Let's begin with AC. AC equals AB plus BC by the segment addition postulate. And then DF equals DE plus EF, also by the segment addition postulate. And then I'm going to use my given information here. I'm going to substitute in DE for BC and EF for AB. So I'm going to write substitution property. Now, since AC is equal to AB plus BC, and DF equals to BC plus AB, which is also AB plus BC, referring to the same segment, by the transitive property, I can say DF is equal to AC. So again, this would be A equal to B, B equal to C, so A equal to C. Okay, so lastly, I can add, which I was talking about earlier, I can add this segment CD to both sides of the equation here by the addition property. And therefore, DF plus CD will be my CF, and then AC plus CD will be my AD, and this will be substitution property. And I have proved it. And this will end the lesson for now, and we will continue to solve more difficult proofs in class.